All right, take some time to read the question thoroughly. Okay, part A says estimate t prime of 7. Show the work that leads to your answer. Indicate units of measure. All right, well, what we'd really like to do is we'd like to be able to take the derivative of this t function and then plug in 7, but they didn't give me the t function. All they gave me was the table right up here. So since I don't have the function to take the derivative of, all I'm doing is just estimating. All right, I'm estimating. We've seen something like this before. I'm trying to estimate t prime of 7. So I find where on the chart t prime of 7 would apply. So it's between these 2 points right in there. And what they're asking is us to estimate t prime of 7 or the slope of the tangent line between those 2 points. Since I don't know anything about the function, the best I can do is just give them the slope between those 2 points. So what I'm going to do is I'm going to do t of 8 minus t of 6 over 8 minus 6, which is equal to 55 minus 62 over 2, or it is equal to negative 7 over 2. And then I see this last part, indicate units of measure, right? That sets off our little alarm bell that we need to make sure we put the units of measure. Well, t prime is going to be a rate. It's going to be a rate of what we consider the y value, degrees Celsius per centimeter. Part B says, write an integral expression in terms of T of x for the average temperature of the wire. Estimate the average temperature of the wire using a trapezoidal Riemann sum with the 4 subintervals indicated by the data. Indicate units of measure. All right, so the key word here is average. When we talk about average, you should think to yourself, oh, that's right, the average value. The average value is that thing that we learned that was 1 over b minus a times the integral between a and b of f of x dx. So now I need to take that and apply it to this problem to find the average temperature. Well, that would be 1 over 8 minus 0 times the integral between 0 and 8 of t of x dx. So now I've done the first part where it says write the integral expression in terms of t of x for the average. There it is. Now I need to do the second part. Estimate the average using a trapezoidal Riemann sum with 4 subintervals indicated by the data, which means I now need to evaluate the integral between 0 and 8 of t of x dx. I'm going to do a trapezoidal Riemann sum to estimate. Remember, the area of a trapezoid is base 1 plus base 2 over 2, which is the average of the bases times the height. But we said sometimes it feels more like the average of the height times the base when we look at it as a picture. Either way you think about it, it's the average of the bases times the height. I take a look at my data from my table up here, and I just start figuring out the trapezoids. If you want to draw the picture, if that helps you out, then draw the picture. The arithmetic of it is going to be base 1, which is 100, plus base 2, 93, over 2, the average of those times the height, which is 1. That's my first trapezoid. Plus my second trapezoid is going to be 93 plus 70 over 2 times the width of this one between 1 and 5, which is going to be 4, plus the third trapezoid, base 1 is 70, base 2 is 62 over 2 times the width of this one, which is 1, plus the final trapezoid, which is the base 1 is 62, base 2 is 55 over 2, then I'm going to have to squeeze in, times 3. So I plug all that in to my calculator and realize that the integral between 0 and 8 of t of x dx is equal to 605.5. I take that and I multiply by 1/8 or divide by 8, and I get the average, my estimation for 1/8 times the integral between 0 and 8 of t of x dx, which is, remember, the average temperature of the wire, is going to be equal to 75.6875. And then I got to remember the last thing, which is indicate units of measure. 75.6875 is in degrees Celsius. Part C says, find the integral between 0 and 8 of t prime of x and indicate units of measure. Explain the meaning of the integral between 0 and 8 of t prime of x dx in terms of the temperature of the wire. We need to figure out what the value of the integral between 0 and 8 of t prime of x dx is. Well, in order to do that, what we're going to need to do is we're going to need to apply them a fundamental theorem of calculus. I know that this is going to be equal to some big F of 8 minus some big F of 0, where this big F is equal to the antiderivative of t prime. So you think about when we learned the fundamental theorem of calculus, we said there's some little f of x, and the antiderivative is big F of x. Well, in this case, little f of x equals t prime of x. So then it stands to reason that big F of x is the antiderivative, so that would just be t of x. So we can come over here and just say that this is equal to t of 8 minus t of 0, which is equal to 55 minus 100, so it's going to be negative 45. In order to explain the meaning of negative 45, we have to realize that t prime is equal to the rate of change of the temperature with respect to the distance. So when I integrate any rate, I get the total. So then the negative 45 would be the degrees Celsius change in temperature from the beginning of the wire to the end. Part D asks, are the data in the table consistent with the assertion that t double prime of x is greater than 0 for every x in the interval 0 to 8? Explain your answer. This is definitely a tough question. We have to think about the second derivative, and all we're given is a table of data right here. The trick to this problem is thinking about t double prime, or thinking about the second derivative t as the rate of change of the rate of change. Right? T prime is the rate of change of t. T double prime is the rate of change of t prime, the derivative of the derivative. So if I look at the rate of change, or if I try to estimate t prime over the interval 1 to 2, 93 minus 100 over 1. So the slope of the tangent line, or t prime, over that first interval is negative 7. And then I look at the other intervals. Like from 1 to 5, the rate of change is 70 minus 93 over 4, which is equal to negative 23 over 4. The next interval, 5 to 6, I'd have 62 minus 70 over 1, which is negative 8. And the final interval, I'd have 55 minus 62 over 2, which is equal to negative 7 over 2. So we're trying to find if t double prime, or the rate of change of t prime, is greater than 0. When I go from this interval to this interval, that rate of change is greater than 0 because negative 7 is less than negative 23 over 4. In order to go from negative 23 over 4 to negative 8, though, the rate of change of t prime has to be negative because the number got more negative. Therefore, we could say that it is not consistent with the second derivative being greater than 0 because there is a range over which the rate of change of t prime gets smaller. That would be this range right here.